I want to provide you with a screencast of information contained in Chapter 19 Waste, Section 1 Solid Waste of our textbook. You've read this section already and you've answered the reading guide questions that go with it, and those address our learning targets that you need to know for the upcoming test. I want to talk about this real quickly to emphasize and reiterate some of the points in there that you should be familiar with so that you are going to do better on the test that we have. In this, we're going to look at some objectives. We're going to look at how waste is generated and space and population, how it affects waste. We're going to see that not all wastes are equal. We'll talk about, of course, the problems with plastics. Solid waste from municipal, which means city or residential waste. Solid waste from manufacturing, mining, agriculture. Landfills, problems safeguarding and building more of those. And finally, a little bit on incinerators. So let's get started. When we get done with this, you should be able to name the characteristics that make something biodegradable. You should be able to identify types of solid waste. You should be able to describe how a modern landfill works, and you should be able to name 2 environmental problems caused by landfills. So let's talk about solid waste to begin with. Solid waste is any discarded solid material, such as garbage, refuse, or sludges. It includes everything: junk mail, coffee grounds, cars. It includes the waste that goes in our toilet. It includes the water that we have waste as a result of our showers, washing food, dishwashing, washing outside our cars. All of these include solid waste. Most of these are taken care of through either our water treatment plants, or they're taken care of through our garbage or recycling. So unfortunately, part of the mentality that has gotten us in trouble is that we are in a society that we buy, we use things once, and then we throw them away. If we were to employ better methods of recycling, reusing, recovering, we would be able to decrease the amount of waste personally, which then all in all in society, we could decrease the amount of waste. And so that takes a change in our actions and our habits and our mentality as well. So hopefully those are some of the things that you've thought about or will begin to think about as a result of this chapter. It turns out that we actually produce about 3 times more waste today than we did in the 1960s. And you can imagine that a great deal of those happen to be plastics, but they happen to be other things as well. We know that towns are running out of space, and we actually began the unit looking at the Mobro in 1987, the garbage barge that was traveled all over the United States trying to get rid of the garbage and had a heck of a time doing that. We know that, and ultimately it ended up back in New York in Islip, and where it was burned and then finally buried. That incident raised awareness for people and really got people to start thinking about recycling. And that's when recycling efforts really took off in the United States. But again, I think we still have areas that we can improve on. So it's harder to get rid of disposed waste because of 2 problems. One, human population continues to grow. And of course, we know that's an element of HIPPO, population growth. More people, more waste. Also, we have a decrease in available land that's available for people to live on. So that's habitat loss. So we have habitat loss and we have population growth are 2 of the problems associated with waste. On average, the United States, we produce about 4.5 pounds of waste per day. Some people produce more, some people produce less. As an example, here's just a chart that shows how the waste has changed. On the right side is the waste per person, and we can see waste generation in pounds per person per day, and right now we're about 4.5 pounds. We were higher in the past and we've actually decreased, which is great, but going back to 1960, that number was down closer to 3.5 or so. Total waste in the United States is the blue line. It's represented on the left side. This happens to be represented by millions of tons. And so we were just under 100 million tons in 1960, and now we're up to 10 million tons in 2010. So that's increased a great deal more than personal waste. Of course, not all wastes are equal. As you know from reading and studying, there are 2 main types of materials, those that are biodegradable and those that are non-biodegradable. Hopefully you remember that biodegradable means that these are materials that through biological processes can be broken back down into their base units. And so paper can be broken back down because it's made of things that organisms can decompose. Non-biodegradable are materials that can't be broken down, and probably the one of most concern for us, the one we generate the most waste, non-biodegradable waste, is plastics. So we know that plant and animal matter are biodegradable. We know that in nature it can be broken down. Fungus, bacteria, other organisms break these down. They include things like newspapers and paper bags, cotton fibers, leather, all typically biodegradable. Synthetic compounds, or the compounds that we make, are not. Those especially include plastics, also polyester and nylon, which are similar. Those are non-biodegradable, so they're around forever, even if they're broken down into smaller pieces. So what's the problem with plastics? Well, they're made from petroleum or a natural material, but they're combined in such a way that they're not found in nature, so there's nothing in nature that can actually break them apart. And that's probably part of the problem here, is that they're going to be around for hundreds or thousands of years. And again, they break into smaller parts, but they don't actually decompose. So they continue to be a problem, especially in ocean environments. So municipal solid waste is the waste produced by households and businesses. So we produce municipal solid waste. So businesses in Park Ridge, our homes, our schools, all part of what's called municipal solid waste. Most of what we generate on a day-to-day basis is exactly this type of a waste. And sometimes this is growing much faster than the amount of mining or agriculture waste that's being produced. And those are sometimes more dangerous, but there's less of it in volume. So this is kind of a breakdown of the municipal solid waste, and you can see from this one that about almost 30% of it's paper. Food waste comprises about 13%, which is pretty close to yard waste. Plastics about 12%, metals 9%, rubber and leather, textiles happen to be 8%, wood is 6%, 6.5%, glass is 4.6%, and this has decreased a lot because we've gone to more plastics, and then there are others. So our biggest waste material is paper. It's included in a lot of packaging, and we do a lot of things using paper, and plastics is down here too. So between these two, we're close to 40% of all waste that we produce is papers and plastics. So solid waste from manufacturing, so companies that are making things, mining, and agriculture. So we indirectly create this waste because we buy the products. And as long as we're buying the products, more of this is going to take place. More mining has to take place, more manufacturing takes place, more agriculture takes place. So we are, in a sense, responsible for these as well because we use these things. Quite often these wastes get leached into rivers, oceans, and lakes, which can be a problem, and that causes habitat degradation. So that's kind of habitat loss as well. So solid waste from manufacturing, mining, agriculture makes up most of the total solid waste produced in the U.S. Agricultural waste, though, are biodegradable, and so they can be broken down because we're talking about waste from our domesticated animals. We're talking about the plants that we are growing, and so most all those are biodegradable. However, we continue to use more and more synthetic products in agriculture, fertilizers and pesticides, and they become very harmful. Fertilizers can get into rivers and oceans. We need to talk about that with water pollution. Pesticides can affect other organisms that ingest them or they're sprayed on, and so these are problems as well. Landfills. About 55% of our waste by weight is stored in landfills. 30% is recycled. About 15% is incinerated. So landfills by far occupy and take up most of our waste. So some key things about landfills is, of course, the waste is buried, and then each day the waste is covered with soil or plastic or both, and it has to be protected so it doesn't come in contact with the soil or groundwater because it can get into other areas and affect organisms in the environment, which then can come back to affect us as well. So one of the things that landfills produces is called leachate. It's the liquid that's oozing out of the garbage as it's decomposing, fermenting, or rotting. And these can contain a lot of things that are really bad. So they can contain pesticides and cleaners, batteries, acids, all sorts of things that are dangerous to have. So those must be sealed into a landfill or funneled off somewhere else so they can be treated a different way. But this is one more problem we have with the waste that we generate. Methane is the other problem. So leachate is one problem, the liquids containing all those poisons and hazardous materials. Methane is the other problem created by landfills. Methane is a gas, it's highly flammable, which is, it can be burned off. It can be used to generate electricity, which is a great way to make double use out of our landfills. So landfills can take in and store our waste. It can also produce methane that can be used to generate electricity to help housing and communities out. If it's not monitored safely, it can be dangerous. It's a greenhouse gas, and it certainly can contribute to global warming and climate change. So we definitely need to take care of methane. So here's just a simple picture of a modern landfill. There's clay liners on the bottom. There's pipes to take out the leachate down here. The liner prevents liquids from leaching into the soil and getting into groundwater. There can be synthetic liners. There's ways of collecting the methane gas. And so materials are buried in here and covered up, and we continue to bury them until we fill them up. And that's in general how they work. And again, the methane can be captured, it can be burned, can be reused, which is the best source of outcome for that. So what law influenced our landfills is the Resource Conservation Recovery Act, RCRA. It's of 1976. It was updated in 1984. This mandated safeguards to be put in place to reduce pollution problems from landfills. This was really important. So the liners and other stuff all came from RCRA. And RCRA did a number of other things too that we'll begin talking about in the upcoming days and activities. So again, running out of space is a problem for new landfills. We're getting better about storage, but it's predicted that many states will lose areas for landfills coming up. And this picture here shows that the lavender has less than 5 years before the landfills have reached capacity. So that's in the Northeast. We see that the tan has 5 to 10 years. So that's in the middle United States and the East as well. Illinois is one of those. And then all the other areas, this lighter green color, is areas that have more than 10 years before they run into landfill problems. But as it states here, the EPA estimates that active landfills in 20 states will be filled to capacity within 10 years. Incinerators is the last thing we need to talk about. And of course, it says in 2006, the U.S. had 103 operational incinerators, and they were capable of burning 94,000 metric tons per day. Just to put that in perspective, Chicago produces about 240,000 tons per day. So the incinerators we have can't even take care of the waste produced by a city the size of Chicago, let alone the rest of the country. So if we hope that this is going to be part of our solution to our problems, we need a lot better incineration facilities. One of the problems with incinerators is, it reduces the amount of solid waste, but it still doesn't disappear. It has to be buried. The ashes have to be buried, and there could be pollutants that are put into the air as a result of the incineration process. So they can become more toxic than they were before. Air pollution needs to be, control devices need to be used to reduce that. And it's possible that small amounts of very poisonous gases and toxic heavy metals can be put into the air from these. So certainly that becomes an air pollution problem. And if these return to the land via rain or other types of precipitation, it can be dangerous for people and communities as well. So this shows how incinerators work. This shows that the conveyor, we're dumping waste in here. It's being picked up and dropped into the furnace. The furnace is burning it. It's boiling water, which we can use to generate electricity to heat buildings. There's a scrubber. The scrubber cleans out, hopefully, dangerous things in the air pollution part of that. They have a precipitator here, which actually tries to knock out the ash so it doesn't go into the air. And then the ash is collected and taken to a landfill to be buried. And of course, the smokestack releases heat and steam mostly, hopefully not as much air pollution, but there still may be some if it gets through the scrubber and the precipitator. And that's the end of the section 19.1. So if you need to review this again, please do this before the test, because it'll be a great way to review the activities and the ideas that you'll be accountable when it comes to test questions. So hopefully this helped you, and have a great day.